So in this video I'm going to be doing a CAM question, and obviously I'll make this question available on Teams so you get all the relevant information for doing it. I just have it in the book here. So the question asks to draw a profile of a clockwise CAM. So remember, it's always important that we know clockwise or anti-clockwise, what direction that CAM is going to go in. To give the following displacement to an inline knife edge follower. So remember, we have our knife edge, our flat and our roller follower. It tells me that there's a 0 to 120 degrees of uniform rise of 36 millimeters. Then we have 120 to 230 degrees of simple harmonic fall of 36 millimeters. And then finally from 330 to 360 there's a period of dual. Okay, and remember, dual is no change in height at all. The center of the cam is 18 millimeters below the nearest approach of the follower. So that's all the information we need to develop up our displacement diagram, and then our cam plate, essentially our radial cam plate. So what I take from this information first of all is, how high is my displacement diagram going to be? Well, I've been told that there's a rise of 36 and then a fall of 36 and then a period of dual. So the highest approach, the highest height of this displacement diagram is obviously going to be 36 millimeters then. So that's going to be the height of my rectangle, of my displacement diagram, as you can see here in the book that's completed. So this height is going to be 36 millimeters. So let's get started. So what I've done already is the kind of simple part of developing this up. So just to show you very quickly what I've done, I measured out, I always go to the left hand side of the page with my displacement diagram, so I give myself enough room for doing the cam here on the right hand side. So the first thing I did, obviously from 0 to 360, I mean, if you wanted, you don't have to do 120 millimeters. You could do a different measurement and divide it up using the line at any angle method that we know now, doing 12 arcs and bringing it up. I just find that the easiest method is to do the length at 120 millimeters. So as you can see, this is 120 millimeters here, and then I've just marked all my different increments at 30 degrees and label that. Okay, then as you can see, I've made the height as 36 millimeters. So I marked up my height 36 millimeters and essentially just drew my rectangle first. Okay, the next thing, so once I had my the diagram, the area where this displacement diagram was going to fall into, I began, and the first thing was from 0 to 120 degrees we have a uniform velocity rise. So all I had to do was essentially join from 0 up to the top of my displacement diagram at 120, and I have this uniform velocity rise of 36 millimeters. So that part is simple enough. The next thing is from 120, so from 120 here to 330, I'm going to have a simple harmonic fall of 36 millimeters. So that means I'm going to have this simple harmonic fall the whole way down to reach the base, so at 0 millimeters height essentially, and then I'm going to have that period of dual. Okay, so what I've done is, on the right hand side I found half of 36, which is obviously 18, and now what I'm going to do is I'm going to divide it up into 6 different sections, and we should all know how to do that by now, just using our 30-60. So let me just divide this up very quickly. And now we have it divided up there. Okay, so the first time we did this question, it was very simple. We had it divided up into 6 here, and we had 6 increments from 150 to 360, so it was just a matter of bringing our horizontal lines across. But you will notice obviously that from 330 to 120, it's not exactly 6 divisions, is it? No. So it therefore is going to be necessary to divide 120 to 330 into 6 different parts, and we should all be capable of doing this now. So I'm going to show you how we're going to do this using the construction method. So at 120, so this point here, and I'm going as far as 330, I want to divide this up into 6. So coming at a line, taking a line at any angle, it doesn't matter, so we all should know this construction now. So I'm just going to come at that angle there, and I'm going to make 6 arcs at any size, doesn't matter, so I'm just after picking a random arc there. Let's go with this here. So 1, 2, 3, 4, 5, and 6. And now what I'm going to do is I'm going to join the 6th one down to our last point on the line. So I want to divide this section up like that. We all should know where I'm going with this now. So I'm going to get me 2 set squares, and now I can draw that line parallel the whole way down. Okay, so using my set square, sliding down parallel. Sometimes it can just be a little tricky getting them lined up. And our last one here. And now you can see that I've divided this from 120 to 360, or to 330, sorry, into 6 different divisions. The next thing I need to do is one by one. So what I'm going to do is bring my first 30 degrees across, make the arc like that, make the line where it's going to meet, bring my point down, and that gets me the first point on our simple harmonic fall. Okay, this point here. The next one. So really what I'm doing here, I don't want to draw big long lines the whole way down because it's unnecessary. I don't want to draw lines the whole way across because again it's unnecessary and it's going to confuse us a little bit. So what I do is I roughly know how far I'm going to need this line down. I draw it down, okay, to here. I come across. So what I might do is I might just label this for everyone. So 0, 30, 60, 90, 20, 50, and then we know that's 180 there. And I'm going to come across now at my 60. Again, I don't need to draw this line the whole way across, so I'm just going to mark it like so. Okay, we have the next point. 90, coming down here. So, now we're nearly there. Nearly on the line with that one. And finally I know the 330 is going to be exactly at the bottom, so if I was to bring that across, obviously. Alright, so what I can do here is I'm going to join all these points up using freehand and to try and get that curved simple harmonic fall the whole way down. Okay. So it's nearly a slow fall, like the slope of a hill coming down now. Okay, and that is from 120 to 330. I'm just going to shade it in, darken it in a little bit better so that we can clearly see. So again, this shouldn't be straight. This is a slow fall from that 36 millimeters. Now when I hit 330 here, I'm essentially just getting my set square and coming across from 330 to 360 because I know that's a period of dwell. Alright, and that is a displacement diagram for this question. So we have our uniform velocity rise, then we have our simple harmonic motion, and then we have a tiny little bit of dwell from 330 to 360. Okay, so the next thing that I need to do is begin developing my cam essentially. So I can come any distance out here. It really doesn't matter how far I come, just knowing that I'm going to have room to have my cam. So I really just go halfway between the edge of my displacement diagram and the side of the page. So that's roughly halfway there. I'm happy enough, and I do believe that I'll have room for my cam. So drawing this line down, this is just a construction line, 2H, and that's where the center is going to run on this vertical line. Now it tells me in the question that the center of the cam is 18 millimeters below the nearest approach of the follower. So therefore what I can do is bring the bottom of my displacement diagram across, like so. I'm going to bring the top across as well. Okay, then I'm going to come and I'm going to mark down 18 from the base of a displacement diagram. So it tells us that in the question, and I'm going to mark that there, and that is going to be the center of my cam, isn't it? That 18 millimeters. So I've marked 18 down from the base. I just did it here, just double checking, and yeah, that looks good to me. Okay, so now, apologies. Okay, so what I was saying was that when I measure down that 18 and to the top of my displacement diagram, that's going to give me the radius of where the cam is going to fall into, okay? So I can bring this up to the top, and then I can draw where my cam is going to place into. Alright, so the next thing is obviously dividing up into 30/60. So let me just draw the horizontal line here. So again, we should all know at this stage how to divide this up. So I'm just going to pause this video, and then when you come back I'll have it all divided up. So as you can see, what I've done is I divided up it into 30/60 and just labeled it all clearly. Obviously it's telling me that it's a clockwise cam, so therefore if it's turning in a clockwise direction, the first increment it's going to hit is 30. So it wouldn't make any sense to have 30 here, because as it turns, the follower is going to hit this 30 here first. Okay, so always remember it's the opposite for clockwise and anti-clockwise in terms of the cams. Okay, so the next thing we need to do is start bringing our heights over to actually create a radial plate cam. So what I'm going to do here is getting my 2H pencil. I'm going to bring across 30 degrees to this vertical line. Okay, I'm going to get my compass. I'm going to rotate it around until it hits 30 degrees like that. Alright, and so on and so forth. So I'm going to bring across 60. Now there's no reason in drawing this line the whole way across. I can just make the arc here, get my compass, and swing it the whole way across to 60. Like so. Okay, and this is finding, what I'm doing here is finding points on the radial cam. So I know therefore that this and this is the 2 points. That's the point at 30 and 60. So what I'm going to do, I'm going to pause now, and I'm going to bring all the different points across, rotate them around, and that's going to create the size or the shape of our cam. Okay. Another important thing here is I just drew this small radial circle, and that's essentially going to be like the shaft that the radial cam plate would be fitting into if it was on a motor or whatever it's connected to. So yeah, when I come back I'll have all this completed. Yeah. So as you can see, I brought all my points over one by one, so from 30, 60, 90, 120, the whole way, one by one, rotated them around to where they are respectively on the radial cam plate. And if you can see, all the different dots where I have are the different points on the plate. Okay, now it's just a matter of joining it up. So obviously freehand and joining up point to point to get the shape of a radial cam. Okay, and that's roughly the shape, so I'm going to go back around it now. And like that there. Alright, so that's the shape we've developed of the radial plate cam. So the shape of that cam we would need if given that displacement diagram. Okay. That's all the information. So the only other thing I would add in would maybe be our knife edge coming down here to show it making contact at the beginning. Now I know the shape might look a bit off, but that's not to worry. If we brought all the points across correctly and everything is in line, well then this is the shape we'd be getting. We have our uniform velocity rise of 36 millimeters from 0 to 120, our simple harmonic fall from 120 to 330, and then finally we have that little bit of dwell, and this is the resultant shape of the cam. So I'll be asking you now to complete this question yourselves, doing the displacement diagram and then the radial plate cam. As well, it's a good thing to do at the end is to add a little bit of colour into the cam that you're after creating. So add a little bit of colour into it just to make it stand out that bit clearly, and make sure everything is labelled clearly as well, so that you have your uniform velocity, simple harmonic fall and dwell labelled also. A border on the page as well. Well, we all know that by now, that's a very important aspect too. Okay, so best of luck with this question.